Why does a log graph look like it does? We have to start by understanding that the log is the inverse of the exponential function. What that means is that the x and the y have been swapped. Okay, so if I kind of do this log to both sides, you'll end up getting x log 10x equals, and then the y comes down the front, and log 10 is just 1, right? So it just equals y. And this is the classic form of log. You ask yourself, 10 to the power of what gives me x? That's how they've defined it to everyone. When you try and sketch an inverse function, an inverse is the x and the y swapped, which means it's literally a reflection in the line y equals x. So how do we then reflect that line in the line y equals x? Well, we need to start by reflecting all of its properties. So this one has an asymptote, at y equals 0. So my log function should have an asymptote at x equals 0. This is an asymptote. Similarly, where the exponential function went through 1, the log function is going to need to go through x equals 1, y equals 0. So it's going to need to go through that point. So it's got an asymptote and it goes through that point. And then from here, we can kind of just do it by symmetry and say that this is going to take off like that. And that right there is the line y equals log 10x. And if you had the natural log, so e, base e, or e to the x, you would do the exact same thing. It's a reflection of e to the x.